Right, well, we are going to try doing our first set of notes through Edpuzzle. We are going to be talking about functions today, and our objectives are to evaluate functions, to identify variables, domain and range of functions, and interpret properties of relations from their graphs. So let's start off with some definitions. What is a function? A function is a set of ordered pairs. And just to clarify, you can be taking your notes in a spiral. You can be taking them on a loose leaf. You can be printing out the pages and filling them in. It's really up to you. I don't want you to stress out. If you're just doing this on paper, that's perfectly fine. I would say make sure you keep all your papers in a binder or a folder where you can have them in order. That's why maybe a spiral is not a bad idea, because then it helps keep it all in order for you. All right, so a function is a set of ordered pairs in which each x value is paired with exactly one y value. And a function is a one-to-one correspondence between two sets. We'll call them A and B, in which each element of A corresponds to exactly one element of B. All right, and in this function, the domain is always going to be your x values. We sometimes call it the input, or we call it the independent variable, which we're going to define down below in just a second. The range is always the y values, which is your output, or your dependent variable. All right, so these are all terms that you've heard before. And independent and dependent are terms we use a lot, and you're expected many times to identify the independent and dependent variables in a situation. And the independent variable is, as we said up above, it's going to be your x. And when you're in a real life scenario, it's the first variable in the relation. It's the thing that we can't do without, and the thing that we have the least control over. For instance, time is always an independent variable, because we usually measure things in terms of time because we can't control time. Time is independent, and then other things depend on the time. For instance, how tall you are depends on how old you are. Maybe another instance could be the time could be independent, and if you're cooking something, how well cooked it is could depend on how long it's been in the oven, that kind of thing. All right, and the dependent variable is the second variable in the relation. It's usually the thing that we're measuring. It's the y. It's the thing. Maybe we're measuring height. Maybe we're measuring weight. And we want to see how those things are changing over time. All right, our first example that we're going to do is a really simple, very, very basic example. And it's about a laundry service that normally charges $1 per shirt for laundering. Customers get a $1 discount if they have 6 or more shirts laundered. Now it doesn't say every time you have 6 shirts laundered you get $1 off. It just says 6 or more you get $1 off. So in this instance, the cost is a function of the number of shirts. So cost is the thing that's changing, that we're measuring, and number of shirts is what affects that cost. So because of that, because this is ultimately what we want to see is what's happening to our cost based on our number of shirts, our independent is the number of shirts. Because when you walk into the laundry service, you don't hand them the money first thing. You hand them the shirts. That's independent. Then they tell you what you owe them. That's the dependent. So when you're trying to figure out, well, which one's independent and which one's dependent, think about what has to happen first. So this is cost. And that's measured in dollars. All right, so now we're going to state the domain and the range of the function. So the domain, as we said, is the number of shirts. We're going to use D for domain, and the domain is the number of shirts. And so we are going to, numbers-wise, say that that is going to be non-negative. You can't be a negative number of shirts, so non-negative integers. Can't have decimals either. You're not going to give them a half of a shirt. So the domain, which is the number of shirts, are the non-negative integers. We could say x greater than 0, and we specified integers so that we know that it's not. No decimals are going to be used there. The range, which we denote by R, is our cost in dollars. This is also going to be non-negative integers because we didn't say anything about tax. We didn't say anything about, again, half of a shirt, so you can't have half of $1. So it's non-negative integers, so that's where y is greater than 0. All right, so let's list 3 ordered pairs in this function. I'll list one, and then I'd like you guys to go ahead and list some ordered pairs. So for instance, if I give the laundry service 2 shirts, I'm going to pay $2. I'd like you to give some other instances of ordered pairs. You can give more than 3, but at least give a couple more instances. Let's see, I'm going to say I could have 5 shirts, that would be $5. I could have 7 shirts, and because I'm 6 or more, I get $1 off, so rather than it being $7, it's 6. If I did 10 shirts, I get $1 off, so it's $9. Alright, so then we're asked to write an equation to express the relation between the cost C and the shirts S. Alright, so when I'm doing that, so cost is C, that's my Y value, and shirts is S, that's my X value. I'm going to go ahead and use X and Y, just so we kind of get used to that. Well, I notice that as long as I'm under 6 shirts, as long as X is greater than 0 and less than 6, then Y simply equals X. I also could have said this domain here, I could have said that X was between 0 and 5 and put an equal sign with the 5, I could write it either one of these ways. All right? Then, when I'm at 6 or more, so when x is greater than or equal to 6, or I could have just said when x is greater than 5, because I specified that x is an integer. So I could have said this inequality either way, then y equals x minus that $1 discount. So I do have to, when I'm writing my equation, have both parts, because it's impossible to only have just the one part because I get that dollar discount. So when I go to graph the function, on the x-axis is going to be my number of shirts, and on my y-axis is my cost in dollars. So let's see here. When I don't have 0 shirts. When I have 1 shirt, it's $1. 2 shirts, it's $2. 3 shirts, it's 3. Because I'm counting by ones, I don't necessarily have to put numbers here. I could. I have to put numbers when it's going to be something other than just counting by ones. I've got to make sure I'm clear what those numbers are. 4 shirts, $4, 5 shirts, $5, but then when I get to 6 shirts, it's also $5. And then, oops, did I put 2 6s there? I sure did. This is 7, sorry. 7 shirts is $6. 8 shirts would be $7. All right, and I am not going to connect these dots, because if I did, that would mean that there's points in between, like there's 1.5 shirts is $1.50, and it's not. This is what we call a discrete graph, because we only include the dots, we don't connect them. We say that it's a continuous graph when we connect it. All right, so then let's look down here at this bottom part. It says find the range of the function f of x equals negative x squared plus 3. I know it says use a graphing calculator. I'm actually going to not use a graphing calculator. I want to see if we can do this without a graphing calculator. I am hoping that you remember that because this is an x squared equation, that this is a quadratic. And because it's negative, my quadratic is turned upside down. So if I was to sketch a graph of this, this would be a quadratic turned upside down and moved up 3 units. 1, 2, 3. And it would look like that. Now, if you did not remember that, you could have pulled this up on your graphing calculator, gone up through, and you would have gotten the same graph here. I can actually show you that right now. All right, so let's go in the graphing calculator, and I've got to clear this out here. And I'm going to put in the equation the negative x squared plus 3. And let's go ahead and graph that. And as you see, it is the quadratic turned upside down and moved 3 units. So if you needed to, you could have used a graphing calculator. All right, so knowing then that this is what our graph would look like for f of x equals negative x squared plus 3, what is the range? The range, remember, are the y values. So when I look at my y values, they never go beyond 3. They're 3 and below, so I could say that y is less than or equal to 3. Some people like to use a different notation, a bracket notation, and we could say that it begins at negative infinity, which would be a soft bracket, and it goes all the way up until 3. So when you do bracket notation, you go from smallest to largest. A soft bracket means that it can't equal that number, and a hard bracket means that it can equal that number. So you could write your range either one.